All right, for your warm-up today, what I'd like for you to do is go ahead and solve questions A through D, making these a proportion. Hey everybody, today we're going to take a look at 4-3 graphing proportional relationships. Before we begin, I want you to go ahead and do your warm-up here. Hit pause, and when you're finished, hit play, and we'll take a look at A through D. All right, everybody, nice job. So go ahead and take a look at your answers for A through D. Now, if you notice, when I first started, I said we were talking about proportional relationships. Now, a proportion really is a ratio, meaning that everything is consistent here. And so these are proportional because of this equal sign. And slope really is a proportion, meaning that the slope of the line continues up, down, or at no slope at a constant rate, giving us the line. We call that direct variation. Okay? So when two quantities, x and y, are proportional, the relationship can be represented by the direct variation equation, y equals mx, where m, where have I seen that letter before? Slope, where m is the constant of proportionality. That's a big word. Okay. Now, if you notice, I don't have a plus or minus here. So when dealing with direct variation, we just have an equation in this form. And I'll come back to that a few times today. So now if you notice, we talked about just a second ago, there's no plus or minus here. What that means is that a line goes through the origin. Okay, so if we notice, it goes right here through the origin. So the graph of y equals mx is a line with a slope of m that passes through the origin. Now, to have direct variation, that means they're proportional. You cannot have a plus or minus here. It's just in this form, y equals mx. So if we take a look at example 1, the cost y in dollars of x gigabytes of data on an internet plan is represented by y equals 10x. Graph the equation, interpret the slope. Okay, so looking at this graph, we have the equation y equals 10x. Now, when we go to graph this, we have our x and y axes. So this is x and this is y. Now you have to be really careful because you do need to graph these appropriately. Your x and y values must match your equation. So y right here is the cost in dollars because, well, I said so. I love saying that, just cracks me up. So x is going to be gigabytes because, again, it says so. So I have the equation y equals 10x. So if I make a quick t-chart to plot this graph, I have 0, 0. When x is 1, y is 10. When x is 2, y is 20. When x is 3, y is 30. Now I can't have a negative number here because I don't have negative gigabytes. So using this, I can do the appropriate scale. Make sure you don't just cram all your data here. Spread it out. So I've got 1, 2, 3, 4, 5 gigabytes. Here, I'm going to count by 10. Now, that's just because my numbers are nice and even here. So I have 0, 0, 1, 2, 2, 20, and then I'm going to graph my line. All right, so let's take a look here at one important word, which means interpret. So I want to interpret the slope. I don't want to know what the slope is. I can look that up. The slope right here is 10. I want to interpret. So my answer is going to be here that this slope represents $10 per gigabyte. Okay, so when it says interpret the slope, that is what we are talking about here. All right, so let's now take a look here at example 2. So it says the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x, the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So y is the weight of an object on Titan, and x is the weight of an object on Earth. So I need to write an equation here. So the first thing I'm going to do is use x and y to find slope, because as you recall, I need to use the equation y equals mx. So my y is 105. Whoops, I apologize. My y is 15. Slope, I don't know yet, and my x is 105. So I'm going to solve for m here. And 15 divided by 105 is actually an ugly decimal. And as if you recall, I said there's no ugly decimals in math. So there's either a math mistake or you need to write your answer as a fraction. Always write as a fraction. No ugly decimals. So when I simplify that, I end up with 1/7. So now the second thing I need to do is to rewrite the equation using slope. Rewrite the equation using slope. So if m is 1/7, I have y equals 1/7 x. So here is my equation. Now, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Well, the weight of Titan is y, so I'm going to replace my variable here with in my equation. So I have 3 5/10 equals 1/7 x. Now I'm going to multiply both sides by the reciprocal, and I end up with 24 5/10 equals x. So my answer here is 24 5/10 pounds. Now we're going to go ahead and skip the on your own 1 and 2 for right now. And then we're going to take a look here at example 3. So the distance y in meters of a 4-person ski lift travels in x seconds is represented by the quantity or the equation y equals 2.5x. Now the graph shows the distance of a 2-person lift. Which one's faster? Well, to be honest, I'm really not sure. So let me kind of break this down a little bit. So the 4-person has an equation of 2 5/10 x. And if I want to know what's faster, that means I'm going to look at the slope here. So what does this slope mean? Well, slope is m. And that means that in this case, we're traveling 2 5/10 meters per second. So now I can compare the slope here to this slope. So let's figure that out. So the 2-person lift, unfortunately, I don't know the slope, but I can figure it out because slope is rise over run. Now, if I go up, let's see, 1, 2, 3, 4, except we're counting by 2s. So this is actually up 8. Here, counting by 1s, over 4. So my slope here is 8/4 or 2. So that means my slope here is 2 meters per second. So which one's faster? Do you want to go 2.5 meters in 1 second or 2 meters in a second? Well, that means our 4-person is faster because it has the greater slope. So in this situation, the greater the slope, the faster the chairlift. Now, what if I had 2 graphs? So here I compared the slope, but let's take a look at this at comparing graphs. So my x and y, this is already the 2-person, so I'm going to use this equation. So x is 0, y is 0, goes through the origin, so it shows direct variation. When x is 1, y is 2.5. When x is 2, y is 5. When x is 3, y is 7.5. So I have 0, 0, 1, 2.5, 2, 5, 3. What is that? 7.5 right there. This line is steeper, so therefore my 4-person is faster. So 4-person is faster because it has a steeper slope. Now, what if I were to look at it as a table? So the table shows the distance y in meters of a T-bar ski lift in x seconds. Compare its speed. So here, this is what I'm looking at. So in 1 second, this one went 2.5 meters. So this one is slower than the 4-person. And here in 1 second, it went 2 meters. So it is faster than the 2-person. Now, I'm going to show you a little trick here too. One of these things is these are proportional, but does it go through the origin? Well, if I take a look, my distance or my difference from here to here is -1. So if I go one more over -1, I'm now at 0. Hopefully, if I look here, I'll end up with 0 again. So here, from here to here, here to here, and here to here, I'm subtracting 2.25. So now my last one, 0, 0. These are proportional, and it goes through the origin. So therefore, this shows direct variation.